Greetings, welcome back to Electronics Component and Device Laboratory, second semester, Unit 1, first experiment. First experiment theory portion I have completed. Go and refer that video. And in this video, I'm going to explain about experiment point of view. What we will going to do in experiment 1, that is identifying the value of passive component. The three passive component, resistor, inductor, and capacitor. The theory portion is discussed in session 1, and experiment 1 will find that value. See, the each in theory portion I have shown how the resistor will be look, and how inductor, how capacitor will be look. If you see that object, the component, electronics component, passive electronics component, you have seen different colors on that body of the resistor. See, that is called resistor color code. There's actually mean each color code represented a unique number. Why they have given a color code, why they have not given a number, all these things I am going to explain. See, we have seen a resistor is a smaller size. It's If you consider any resistor, it will be less than 0.5 centimeter. In that 0.5 centimeter, we will not be able to print all the character that actually resistor value and wattage rating. All these things will not be able to print it on a smaller body of the resistor. See, that's why they have come up with a concept called as a printing on a color bands on the resistor. The color represented a number, and with that help of number we can identify the actual value of the resistor. This process we call that is a resistor color code. The resistors are manufactured with the preferred value. Each resistor is a component. While they're manufacturing, each resistor have a preferred value. That value uh, we need to print it on that, we need to label on that devices, on the body of the devices, but it is not able to do it. Why? Because means it's a size constraint. The larger size is not available. See, for that they are using a color code on the body of the resistor. They printed on the value, and that their body, in the colored ink band, there is a color band on that resistor body, that is called resistor color code. See, this is the reason. See, device has a smaller size, means each printable character will not be printed on the devices. For that they are using the color code, and the resistor color code is made up of group of colors. How they will be made? Resistor means there is a group of color. Some resistor have a 4 color, some resistor have 5 color, some resistor have 6 color. We'll see it. There's a group of colors. Each color have a number. Each color have a number and a tolerance value. There is a tolerance value also. Each color is represented a number, and it's in most cases the tolerance value also. The resistance value, tolerance, and the wattage rating are generally printed on the body of the resistor. If resistor has the number or the letter when the resistor body is a big. There are some resistor have a body sizes are large. For example, if you consider power resistor, that is a wire one resistor, rheostat, potential meter, all these things is a larger size. The body have a larger size. There is a sufficient space to write the character. That's why on that rheostat and potential meter, they have printed that resistor value and the wattage rating, everything in a printable character. But if you consider the 1/4 of wattage, 1/4, the smaller power resistor, that is a carbon resistor or film resistor, the size is very less. The color printed character cannot be printed on that. It is not able to read also. That's why they use the color band. So the color band look like this. So this is the actual resistor. It's a cylindrical shape and it's a smaller size. It is enlarged here in this picture. There are 4 colors here. See, the color band, the number of color bands have a unique representation. There may be a 4 band resistor, there may be a 5 band resistor. Means some resistor have a 4 band. If you count this, first band, second band, third band, fourth band. See, that's called 4th band. 5 band means there may be a 5 colors on that resistor body. That's called 5 band. See, the 4 band represented, first band represent the first digit, and second band represent the digit. Third band represent multiplier. Multiplier means 10 raised to the power of. See, there is a color. Each color have a number. That number will be placed here. That's why they call that as a multiplier. And last band is called tolerance. Tolerance means it's a accuracy. It's represented the range of the resistor value. How it will going to vary. That is called as a tolerance. If it is the 5th band, the first three band represented digit 1, digit 2, digit 3, and the fourth band represent multiplier, and fifth band represented tolerance. So how they will finding the see, it has to start with this one only, left only, first, second, third, and fourth. How it will be? See, one has to carry the resistor in the left hand, holding like this, and they need to count from the left to right. See, if they taken a reverse, the resistor color code will be gives a different value. See, for that, one has to hold the resistor in a left hand, and it has to start with color code, first band, second band, third band, like that they have to do. This is called resistor color. Resistor color code may have 4 band or a 5 band. Some resistor may have 6 band. See, this is called resistance color code. Each color code have a specific number. I have told in a previous slide. Black means 0, brown means 1, and red is 2. See, like this, there is a 9 colors, and there is a gold and silver and none. The gold and silver represented tolerance also. That means plus or minus 5% tolerance. Silver represent plus or minus 10% and 20%. And multiplier means 10 raised to the power of 1. Means 10 raised to the power of 0. Here black color means it's a 0. 10 raised to the power of 0 means it's a value 1. Brown, it's a 10 raised to the power of 1. It's nothing but 10. Red, 10 raised to the power of 2. 10 raised to the power of 2 means 10 into 10, it's 100. Orange, 10 raised to the power of 3, that is a 10 into 10 into 10, it's a 1000. Yellow, 10 raised to the power of 4, it's a 10,000. Like this is a multiplier. They are represented in terms of kilos. We call prefix 10 kilo, 100 kilo, 1 mega, 10 mega, 100 mega, and 1 gigo. And this is also tolerance. There may be some brown and red color. If it is brown, it's a 1% tolerance. Red is a 2% tolerance. Most of the resistor have a gold, silver, and none. None means no color. No color means no fourth band is represented a none. It's a represent tolerance. It's a 20%. This is about the color code table. See, we need to remember all these things in order wise, because while seeing this color band, how can we say it's a first band, it's a red color. Red color means what color? It's a 2. See, we need to write here 2, and here this color is a blue color. See, for the blue color represented 6. Here we need to write 6, second digit. And third color is a gray. Gray means it's 8. 10 raised to the power of 8, it's a multiplier. We need to make it 10 raised to the power of 8 multiplier. And plus or minus, what is this? Gold color. For the gold color, it's a plus or minus 5%. The 5% is the tolerance. Like this, we need to calculate the resistor, and we should remember this color band. For that, there is a saying, B.B. Roy of Great Britain has a very good wife. B means black, brown, red, orange, yellow, green. G means gray, green color, and blue is a B means blue, V means violet, G means gold, and W means white. See, like this we can arrange in this way. That's a representation. If you remember this statement, you can easily remember the digit also. It's a 0 digit. This 0, 1, 2, 3, 4, 5, 6, 7, and 8. 8 is a gray, and 9 is a white. So this is a 9, and you should remember gold and silver, it's a 5%, 10%. No color means 20%. This is accuracy. Here I have given some example. There are the 2 example of a resistor color code, 4 band resistor and 5 band resistor. 4 band resistor, first band is represented a digit. This is a brown color. Brown color means it's a 1, it's a red water 1. And second one is a red color. Red color means it's a 2, it's a 2. They have written 2. And third band is a multiplier. The third band looks like a brown. It's a 10 raised to the power of 1 means it's a 10. That is a 120. And last band, it's a tolerance, plus or minus 5%. This is the actual value of this resistor. And like that, there is a fifth band also. In that fifth band, they use 1, 2, 3 are the first 3 digit, like a first digit. Yellow means it's a 4. They have written 4. And violet, it's a 7. First band, second digit. And a black means 0, it's a third digit. And multiplier means it's a brown, it's a 1, that is a 10. They need to multiply 10, it's nothing but 0. It's a 4700. And brown means plus or minus 1%. It's a 1%, it's accuracy. 4700 can be written like a 4.7 kilo ohm. We can make it specific. It's a 4.7 kilo ohm plus or minus 1%. This is the way we can calculate the resistor value with the help of color code mentioned in the resistor band. See, this way you have to do in your laboratory. And we come up with the tolerance. What is mean by tolerance? Why tolerance is required? The tolerance represents the accuracy of the resistor value. See, while manufacturing the resistor have a resistance value, but while manufacturing they may not be accurately manufacture the resistor value. That's why there is some deviation. That deviation can be represented with the help of tolerance. That says about the region. That means each resistor device may weigh there may be a chances of varying the resistance value while using. That can be mentioned in with the help of tolerance. The percentage variation between the marked value and the actual value. The marked value means printed on the resistor body while doing manufacturing, and when we do connected using the ohm meter, and while we are using circuit, there may be changes in the value. That differences we call that as a tolerance. The precision resistor are commonly used by the 5 band. That means if you need an accurate resistor value, there may be some application demand like a military, and there may be some defenses. Most like ISRO, they are launching the space satellite. For that they need some high accuracy precision rectifier, precision resistor. So for that they use 5 band or 6 band color band. In that first 3 bands represented the digit, and first 3 significant digit, and 4th band is a multiplier, and 5th band represent the tolerance value. And there somewhere 6th band also is available. This is about the resistor color code. And there is some resistor. This resistor are called through hole resistor. Through hole means while placing on the printed circuit board, they need to hole, and they have to place the resistor inside the hole, and they need to solder it. That's called, they call through hole devices. There are some surface mount resistor also is available. Surface mount resistor, they in PCB they will not going to put hole, just they will place the resistor and they will solder at each edge. See, this is the point, connecting point. If they solder here, it will be surface, it's placed on the surface mount. That's why it's called as a surface mount resistor. In surface mount resistor, they doesn't have a color code, they have a number printed on, like one example 473 472. 472 in this means first digit, second digit, it's a 47, and third digit represent multiplier. Multiplier means a 10 raised to the power of 2. 10 raised to the power of 2, it's a 10 into 10, that means 100. They need to multiply 100, it's a 4700, that's nothing but 4.7 kilo ohm. This is a way we can calculate the resistance value for the surface mount resistor. See, this is a one chart gives everything whatever I explained till this point. It's given here. The resistor have 4 band. It means it's a first band, second band, third band, and there is a tolerance also. We can calculate like here. There may be some 5 band resistor also, accurate, more accurate one. First 3 are digit, and 4th one is multiplier, and 5th one is a tolerance also. 5th band, 5 band resistor, that is a reliability. That means first, second is a digit, and there is a multiplier also, there is a tolerance also. Last means it's talking about the reliability, how accurate, how reliable that resistor. And there is a 6 band resistor also, it's a more accurately, it's a first digit, second digit, third digit, multiplier, tolerance. And the 4th one will talking about temperature coefficients. The temperature coefficients here, they represent brown color means 100 ppm, red means 50 ppm, orange means 15 ppm. These are all more accurate resistors. In lab purpose we are not using, but in industry they are using 5 band and 6 band resistor. Why? Because they need an accurate value of resistor, and they need a reliable resistor value, and with the temperature coefficient also. And here in this way we can, K means it's a 1000, M means it's a mega, that is a 10 raised to the power of 6, how they will be prefixed. And there are some example also. Resistor color code, this is the table I have explained. BB Raf, Great Britain, have a very good wife. And surface mount resistor, see there are plenty of example here. 101 means it's a 10 into 10 raised to the power of 1, it's a 100 ohm. 105, 10 into 10 raised to the power of 5, that means it's 5 zeros we need to put after 10. This is the equivalent value. 2 to 4 means 22 into 10 raised to the power of 4. There are some zeros here. R0, that is a 1. R means it's a ohm. 0 means it's a 10 raised to the power of 0, it's a 1, that is a 1 ohm resistor. 22R, that is 22.0. there is no digit multiplier, there is not multiplier, that means it's a 22 ohm. R1010, that is a 0.1 ohm resistor. Like this they are represented in a surface mount also. There is a 4 digit label also. Here it's a 3 digit and 4 digit. The 4th here 100 is the value of the resistor, first digit, second digit, third digit, and 1 means it's a 10 raised to the power of 1. This is about multiplier. And 22 R0, that is 22.0. R means 0. This is represented above multiplier. Like this, we can have a different value of resistor. Then coming to color code, capacitor also have a color code. The same order is there, but the way of calculating is somewhat different. Instead of band 1, band 2, they are using digit A, digit B, and digit D. Digit D is a multiplier, and there is a tolerance also. The tolerance have a two specification. One is greater than 10 picofarad and less than 10 picofarad. It depends upon the capacitor value. If it is the capacitor is greater than 10 picofarad, we need to use this as a tolerance. If it is less than 10 picofarad, we have to use this one. And temperature coefficient also, there is a temperature coefficient also mentioned in the capacitor color code. And this is about tolerance value. Instead of writing the color, they may have written a alphabet B, C, D, F. It means there is a tolerance value. So B represented means 0.1 if the capacitance value is less than 10 picofarad. If it is greater than 10 picofarad, there is no B. Like this way we can use the tolerance value. And this is about color code. The color printed on the capacitor, usually metallized polyester capacitor or disc ceramic capacitor they have printed. We should hold like the color should be banded on the top, and terminal has to pointed at the towards the earth. The first band represent A, second B, and D V. That is, A means it's a first digit, B means second digit, D means multiplier, T means it's a tolerance, and V means it's a voltage rating. And all the ceramic values of picofarad, they are represented in terms of picofarad. They need to multiply with a picofarad. And there is a ceramic capacitor also, like this. They have to hold the capacitor in this way. First is A digit, B digit, and D. D is a multiplier and T is a tolerance also. There is a voltage rating also. Like this, capacitance value can be measured. And these are all the different way. The color can be printed on ABD or ABDV. That's a 4 color. V means it's a voltage rating, and ABD T is a tolerance. There is a voltage rating also. ABDT, this way there is a temperature coefficient also. It's a color, and there may be sometime reverse. During that time, we have to take it from the top A, B, D, like this. See, that's why there is a different combination of the color printed on the capacitor. That's a usually ceramic capacitor or a metal polyester capacitor. We should use this way to calculate the capacitor value. And there is a one more type of capacitor value, that is called ceramic capacitor. Ceramic capacitor, there will be digit printed like in resistor, surface mount resistor. What we see, it's 4 to 7, like that. It's having a digit printed on the ceramic capacitor value. This digit can be used to calculate the capacitance value. That is our first digit and second digit. 1 is a first digit, second digit is the 5, and 1 is a multiplier. That's a 10 raised to the power of 1. It's a 10. That is a 1, 5, 0, and K represent the tolerance value. That K, we have to go and refer this one. It's a K value. This K value, it's a picofarad. The ceramic capacitor all in a picofarad range. That's a picofarad range, 10%. See, that is a 10%, plus or minus 10% is the tolerance value, and unit will be picofarad. The final calculation will be 150 picofarad plus or minus 10% is the tolerance value. Like this, we can calculate the ceramic resistor value. And this is the each digit capacitor table. See, we have 15K like that. What is that? See, 0 to 5, we can use this as a digit and multiplier. If it is 5 means it's a 10 raised to the power of 5. 8, 9, if it is 8, they have to multiply 0.01. 9 means it's a 0.1, and the tolerance will be differences if it is 10 picofarad or less than 10 picofarad. And letter, there is a different letter combination also. Tolerance for more than 10 picofarad, there is a 10 tolerance we need to follow. And this different types of capacitor and their respective value also. Here you can say polyester film, it's have represented a number 2 to 1 J, that is a 22. 1 means 10 raised to the power of 1. J means it's a what is the J? It's a plus or minus 5%. That is a color code. You have to go back and refer. It's a J. J is a 5% tolerance value. See, like this, it's a 22 1J, and all these things are represented in terms of picofarad. first digit, second digit and multiplier in picofarad or a microfarad if decimal point, decimal before the digit. If there is a decimal here, if you carefully observe, it's a point. If it is point means it's a micro. Here it's a 0.22j. 0.22 dj is a microfarad, all other picofarad. And there are tantalum capacitor, it's a color code is printed, each color code I have given, and there is a metallized polystyrene film. There is a value printed on 2 micro 2 100 volt means voltage rating 2 microfarad, and it's a 2.2 microfarad actual value. And polystyrene color code, this I would explain. And surface mount ceramic capacitor A1, it's each character represented 1.0 is a meaning, and 1 there is a multiplier. 1 means it's a 10, the out represented A means it's a 1.0 into 1, it's a 10. Like this they have calculated the value. And SMD electrolyte have a polarity, positive polarity and negative polarity. Here plus is represented, and 10.6 voltage, and AA475 475, this is the value. And there is electrolyte also, here negative sign is there, positive sign, actual value is printed, and voltage rating is also printed. Like this there may be some capacitor, it's having a shape of resistor also. There is a color code that can be calculated. So, and this is a ceramic disc, this I have covered 2 digit and multiplier with a picofarad ceramic label. So these are all the different way we can calculate the capacitor value, and with the help of color code and digit printed on the body of the capacitor. Then coming to inductors look like somewhere resistor also, they have color band also, 4 band. So first 2 band are digit, and third band is a multiplier, and fourth band is a tolerance. There may be sometime they mention the symbol also, BC, SY, like this they may represented alphabet. This alphabet can represented a tolerance. Like this they have printed 223K, like what we have seen in surface mount resistor, they have printed number, no, like that. In a inductor also they can print it. If they have printed the number, first 2 are digit, these 2 are the first digit, second digit, and third one is a multiplier, and K is a tolerance. K means it's a plus or minus 10%. Like this we can calculate. Either they can use the color code, or they can printed a value. With their printed value we can convert that into an inductor value. And inductor also have a same color code, same order also, there is no change also, but the difference is a first band 0 to 9, second band 0 to 9, and multiplier they use only 1, 10, 100, 1000 and 10 raised to the power of 4. So this way. And there is a tolerance also. This is usually used in a military because they need a more accurate value, and for that they have a tolerance of military value. Here 4 band color code, unit will be microhenry. See here the 4 band, that is a red, it's a 2, and violet it's a 7, 2, 7, and brown means it's a 10, 270, and microhenry. Gold means it's a 5% tolerance value. This is a normally resistor value, and this 5 band resistor value, it's used in a military identification. Same thing they will use first 2 digit 3 digit multiplier and tolerance also. Okay, see, you have to take active component what we give in our laboratory. You have to take resistor, multiple resistor, and multiple capacitor and inductor. You need to find out the value of with the help of color code, and with the help of the digit printed on that one. This is the first experiment. You have to do this, and you have to practice this more. Thank you.